So hello guys, welcome back to the lab of CSEJJ. Today as usual we're going to explain a theory of electronic device, that is what is diode and the operation of forward bias and reverse bias. So Chuan, explain to us what is diode.
Okay, thanks Zach. So today we are going to talk about diodes. Okay, and when I say diode, I want you to remember that semiconductor, they are both related. Okay, diode, semiconductor, diode and semiconductor. Okay, so that is probably a small semiconductor material. It's made out of a small semiconductor material, and usually we use germanium, silicon, and gallium arsenide as the material. Half of the diode is doped as P region and the other half is N region. There are two things between the regions, which are PN junction and depletion regions. My friends are going to talk about it later. So let's just concentrate on the P region and the N region. P region will act as anode, which connect to the first conductor terminal to the voltage sources, and N region will be cathode that connect to the second conductive terminal. It will change due to the bias process, which are forward bias and reverse bias.
Okay, thanks Chuan. So now let Chun to amaze us by his explanation of the forward bias.
Okay, thanks Jack. So now I'm going to talk about what is forward bias. To bias a diode, we should apply a DC voltage across the diode. So actually, this is a simple diagram of a diode. So if for forward bias, the current can pass through from the P region to the N region. As long as it can pass through this PN junction, it is considered as a forward bias.
When connecting the circuit, the diode is connected in series with the resistor. The resistor is used to limit the current that passes through the diode. This is to prevent the diode from being damaged. The P region is connected to the positive V bias, and the N region is connected to the negative V bias. This is one of the requirements for the forward bias. So for the second requirement is that the bias voltage must be greater than the barrier potential. Mostly, the barrier potential for germanium is 0.3 volt and silicon is 0.7 volt. And for the reverse bias, my friend CHUAH will explain more about it.
Okay. Next, the theory of the reverse bias will be introduced by CHUAH.
Okay, thanks to Jack. Now I would like to explain the reverse bias to you all. The reverse bias is to prevent the currents flow to the diode. To set up the reverse bias, the positive of V bias is connected to the N regions and the negative side of V bias is connected to the P regions. Okay, now I would like to show the demo to you.
AC current. AC current will change the direction of the flow of current. Diode. Diode is limiting the current flow in one way only. So we connect AC current and diode in a circuit. When it is negative half cycle, the current cannot flow through diode. So that halfway rectifier graph is shown. When there is strong enough voltage, it will break the diode.
So last of today, JJ will be here to explain to you guys about the graph of VI for the forward bias and reverse bias. Welcome JJ.
Thanks Jax. I will now briefly explain about the VI graph of forward bias and reverse bias. So as we can see in the graph, the forward current increased very little until the forward voltage across the PN junction reached approximately 0.7 volt at the knee of the curve, which is the barrier potential. After this point, the forward voltage remains nearly constant at approximately 0.7 volt, but the IF increases rapidly. As previously mentioned, there is a slightly increase in VF above 0.7 volt as the current increase due mainly to the voltage drop across the dynamic resistance. When a reverse bias voltage is applied across a diode, there is only a an extremely small reverse current through the PN junction. With 0 volt across the diode, there is no reverse current. As you gradually increase the reverse bias voltage, there is a very small reverse current and the voltage across the diode increases. When the applied bias voltage is increased to a value where the reverse voltage across the diode reaches the breakdown value, the reverse current begins to increase rapidly. As you continue to increase the bias voltage, the current continues to increase very rapidly, but the voltage across the diode increases very little above VBR. Breakdown, with exceptions, is not a normal mode of operation for most PN junction.
So that's all for today. Thanks for watching.
So if you have any question, do comment below and give us a like.
And remember, don't ask your friend.
Your friends are
Mambo!